So let's return to our example of rehearsing the Second Amendment, trying to memorize that amendment. As we rehearse it a few times and we maybe wait a moment or two, we might have pretty good access, good retrieval strength to that. And the idea there was that the loops of neural activity have caused a temporary increase in some of those connections, and so we can retrieve that information for a short time. But we're going to lose that as these neural connections get weaker again. Remember, the hippocampus is a key structure in this memory system, and the interesting finding there was that as we learn new things, we get high activity in the hippocampus, but with repeated presentations, activity in the hippocampus can actually go down. And remember, that was a possible explanation for Bjork's claim that when we have high retrieval strength, we might not be able to make much of an increase in the storage strength under those conditions. Of course, as we rehearse, we're going to increase our storage strength, right? But we can get to a point, he argues, where when the retrieval strength is really high, it's hard to actually increase the storage strength. Well, what can increase the storage strength? Well, over time, then, as we go to sleep, for example, what appears to be happening is the hippocampus seems to be involved in this process called consolidation. And the way we thought about that was by suggesting that the hippocampal system can teach the cortex, in a sense. And that's this notion of taking the information, the Second Amendment, from a sort of a short-term system or a hippocampal system that has a fast rate of decay and transferring the memory for the Second Amendment into cortical locations that have a slower rate of decay. And that's what we mean by then long-term storage, long-term memory. We call that process consolidation. And some of this consolidation may be happening during sleep. And this is why some research has shown that sleep definitely does enhance the performance of memory and the performance of people who get that sleep compared to people who don't get that sleep. So the consolidation process then is going to be causing an increase then in the storage strength, right? And remember then, this is referring to the memory for the information being transferred, if you will, to the cortical areas that will encode the memory. Incidentally, notice that as the storage strength increases, then we're going to show also an increase in the retrieval strength, because now we've got the information better stored in our long-term system. So, for Bjork, then, he's got some suggestions as to how best to increase the storage strength. Well, one, would be kind of sleep, right, and just let the hippocampal system teach the cortex, right? That's the consolidation process. But there are also deliberate things we can do to increase storage strength. And here's one major idea in his research, and that is to make retrieval more difficult. In other words, create conditions of low retrieval strength, and then try to retrieve the information. And he argues this leads to greater gains in storage strength, and so better long-term retention. One way to do that is to space out your study sessions, right? Another way is to use tests rather than rereading information. So let's take a look at those two. So here's the idea, that when we first are rehearsing the Second Amendment, right, we have high retrieval strength, but it will quickly decay. Now, the hippocampal system will consolidate a bit for us here, so that's good. But Bjork argues what you want to do is to wait, the duration, as you kind of spread out your study session, what you're doing is you're kind of guaranteeing you're going to be at a lower retrieval strength than when you were busy rehearsing it the first time. So by spacing out your study sessions, you are setting up a situation where retrieval will be more difficult. The retrieval strength is lower than when you were first rehearsing it. And so he argues that delay is good. That's what he means by spacing out the study. The spacing of the study sessions means that your retrieval strength will be lower than it was at its highest point during the initial learning. And then when you've waited here, then the reactivation of that information, he argues, is going to cause a boost in the storage strength. And that's what tests do. Tests force the retrieval system of the brain, the memory system, to access that information. The act of using that retrieval system, he argues, is especially helpful for increasing storage strength. Now, rereading does not do that. Yes, you'll put the Second Amendment back into working memory, but you never had to utilize the frontal lobe retrieval systems to access the information. He argues that the testing, or the retrieval, which tests force, is better for long-term storage than just representing the material. Notice when we have high storage strength, because we've had a couple of study sessions here, that's going to lead to a slower rate of decay of the retrieval strength, right? So that was that relationship between storage and retrieval strength. As we increase the storage strength, then the retrieval strength decays at a slower rate. When it's well learned, we'll be able to remember it for a while. But over time, we can lose access to that information, and that's what forgetting would be. Now, what's the evidence that tests are beneficial this way? Well, here's a typical study. So subjects read passages, some subjects restudy the information, some take a free recall comprehension test, and then 5 minutes later they're given a test of the information, how much they remember. The study condition shows greater recall 5 minutes after the initial studying. But after 2 or 7 days, the study test condition showed greater recall. So for short-term recall, the study condition is better. But for longer-term recall, study test condition was better. In another study, subjects read a prose passage 4 times consecutively. So that would be the study condition. Or they read it 3 times, study, and then take the test type thing. Or maybe they read it once and then have 3 episodes of testing. And again, the study condition was best for the assessment test after 5 minutes. But any condition that had a testing episode in there, those were better for longer intervals of time, so 1 week test. Now, interestingly, the students reported that the study condition was the least interesting, but they thought they would learn the most, right? In other words, they may be discounting the value of testing as an enhancement of long-term memory. And this is one of Bjork's points, that tests are learning opportunities, not simply assessments of prior learning. And in the discourse on education, we often hear about standardized testing and so on to assess what do people know. His argument is that these tests are more valuable than just assessments. They're actually great learning opportunities. Why is that? Because they force retrieval. And when you activate the retrieval system, that enhances consolidation. You get greater gains in storage strength. And so, unfortunately, students may be discounting the benefits of testing on memory. But tests do have these other positive virtues as well. They're good diagnostic instruments. If students want to know how well they know something, testing themselves or having others quiz them is one of the best ways. Of course, it retards forgetting and also potentiates later study. So future study sessions are better after a test. Now, this idea of making retrieval more difficult is one example of what Bjork calls desirable difficulties. So by difficulties, he means, difficulties in the learning process. So we might experience them as more challenging or more of a struggle or more difficult, but they're desirable because they lead to better long-term retention of the information. So one of these desirable difficulties is to make retrieval more difficult. And so why is it that this helps long-term retention? Well, a couple possibilities Bjork offers. One, that retrieval searches may result in deep processing of the information. So if you're struggling to retrieve the information, you may be sort of activating other related concepts and ideas as a way of getting at the target information, and that process strengthens those associations, and that will make retrieval later more easy. In addition, just the retrieval system itself is getting practice. So the frontal lobe retrieval systems may be getting stronger, more efficient. They become more effective for later retrievals. So the more we use this retrieval system, the better it will be. So in general, a little take-home message: the more difficult a successful retrieval, the more potent the learning. Now notice the successful is there. Ideally, you do want to be in a situation where you have to try to remember something, but then have access to the answer as well, so that you can make those associations. Another way to introduce a desirable difficulties has to do with the encoding of the information in the first place. So not the retrieval, but rather the how you study. And one example of that would be contextual interference. In this example, the idea here is to change study locations and times. And now that might appear to impede learning in the short term, but it's better, again, for long-term retention. Here's some simple studies that were done in the past. So we have students study some information in 2 different places or in the same place, and then they're tested in a third room. Recall for the information was better if they studied the information in 2 separate rooms. Right, so in other words, changing the context of study led to better recall of the information. Now, there is this phenomenon called state-dependent learning, where recall will be better if you're being tested in the same room as what you studied in. But this is a slightly different experiment, that by studying in 2 different places, that's leading to better recall than studying in the same place when tested in a third room, a different room. Now, why would this work? And one idea here is that what you're doing is you're increasing the variability of the encoding process, and that's increasing the number of cues, both environmental, mood, body states, that are associated with the information. That's going to enhance retention. You'll have more access to the information if there are more sort of retrieval handles, because there was more variability in the encoding of the information. Another example of making sort of the encoding the learning process more difficult, but in a desirable way, is what he calls interleaving versus blocking. Now, blocking is when you study one type of thing over and over again, and then go on to some other type of thing, and you repeat that over and over again. A motor example would be, if you're going to practice your tennis strokes, maybe you'll do 100 backhands, then you'll do 100 forehands, and you'll do 100 overheads. That would be blocking or mass study. Bjork argues that there's evidence that a different type of approach is more effective, and we'll take that up in the next section.